Here we have a law of cosines problem asking us to solve this given triangle. They've provided us with two sides and the angle that is included between those two sides. So for this particular problem, we know that the very first thing we're going to be able to find is little c. And I know that because I have side angle side, and that's always going to pair up with the ability to find a side length. I also can tell because I'm given big C, which matches up. I also can just go in and say, well, look, c squared is equal to a squared plus b squared, which, by the way, that resembles our Pythagorean theorem, minus 2ab cosine of big C. So I know this is a form that I can use, that I can work with. I think it's a little odd that the formula gets set up this way most of the time, just because I almost always do something to the formula to go ahead and put this square root on both sides of my equation. Now, it doesn't appear on the left because the square root of a square, well, those are inverse operations. They negate each other, essentially. So we actually know that little c is going to equal this huge mess here, but we know that little a, little b, and big C are things that we were given, keeping in mind that little a is always across from big A, and little b is always across from big B. I should point out that I wouldn't have to use A, B, and C as the lettering arrangement here. Just the general structure, the general idea of what's going on is what matters. But all that means for this part, at least, is we can just plug right into our formula. And so here what I'm going to do is just go ahead and jot this down. Little a is 29, little b is 13, and so I'll do the same thing here. Little a is 29, little b is 13, and they've given us our angle of 41 degrees as well. Now my big shout out, my big warning to anyone watching this video is if you are using a calculator of any kind, please make sure that if it has the option to change between modes in any way, which most major calculators do, especially if they involve sine, cosine, and tangent, make sure, for example, on this TI-84, there is an option for radians or degrees here. You want to make sure you're in degree mode. Notice it was 41 degrees, not 41 radians. 41 degrees. So if I had had this in radian mode, I could get some very far-fetched answers. The same would be true if you're using anything like Desmos or the Google online calculator. Any of those things have the option to switch between radians and degrees. You just need to know your respective place to work. So I'm going to back out of that. Notice here, I'm not doing any scrap work. If you are patient and careful with plugging things into a calculator, especially if it's one like this calculator is really nice because I can just go in and I can type in all of these values all at once without ever simplifying anything at all. Now, if you're using something like a Google calculator, I don't know that it's that cooperative. You may have to do this part by part. I know that Desmos, you can absolutely type this in the way that I have here. And we see about 20.9987, depending on how you want to round this. I think this one is close enough that I'd be very comfortable rounding this to 21. No matter how I round it otherwise, I'd have to go all the way back here somewhere before it doesn't bump things up in some way. So I'm going to call this 21. And so this is going to be the side length for C. And that's little c. And be careful, that almost looked like 211 there. All right. We're not done. It said to solve the triangle, and all we've done is find one little side length. We still need the angle of big B and the angle of big A. Now, for the sake of alphabet, we'll just go ahead and find the measure of angle A. And what we're going to do is remember our alternative form for this formula. We know that to find an angle, it's always going to be the inverse cosine in some way, but we need to lead off with whichever variable we're working with. So I have big A here, so I want little a squared to be the first thing that I write down. And if I'm thinking back up here, this had a positive a squared and a positive b squared. It had positive square terms here. This was the opposite. We were going to subtract some things from both sides. So we had minus b squared minus c squared. And then we always needed to take care of the -2 pair of variables here. The two things that go down here with this -2 are always the two variables at the end of the top, so we need the b and the c down here. So to find the measure of angle A, I want the cosine inverse of all of this. So in this problem, we'll just replace our values now. Hopefully I left enough room here. Little a is 29, again. B is 13. C we just found to be 21. So then negative 2 times 13 times 21. Now while I'm making a note, or rather while I'm finding this value, I would like to make a note that sometimes these forms here will look a little different if you look online for other resources. Mathematicians can be a little stingy about negative signs, and so what they often do is they factor a negative out of the top and bottom to create an alternative form of this equation. So if you see slightly different formulas, they're not necessarily wrong, they may just be alternative ways of doing this. I think that it just adds an extra layer that we don't need. So what I'm going to do then is just do what I've been doing here and get this angle, if we round to a whole number, 115 degrees. So we're going to say approximately 115 degrees. It is a rounded value, keep that in mind. But our measure of angle A is approximately 115 degrees. And you may look at that and go, wow, that was a lot. I don't want to do that again. That's too much. And the good news is you don't have to. Please never forget that triangles, their angles always sum up to 180 degrees, and we know two angles. We have C and we have A, and we know that the measure of angle B is just going to be 180 minus these two angle measures. We'll subtract those away, and whatever's left is going to be the angle we're looking for angle B. Now I am going to put an approximate symbol here as well, because this is using a rounded value. It feels a little weird to say that it's definitively this. So we're going to subtract 115 and 41, and we're going to see that we have an angle of approximately 24 degrees. And there we go. We had the measure of angle A, the measure of angle B, and we have little c. And it's all there on the screen for you to pause, take a look back over, and that's that.